All right, guys. So before we get started with today's notes, are there any questions on any of the assignments thus far? Yes. So the first thing we're going to start off is finding the value for sine and cosine. So for the first one here, we have sine of 62 degrees. So I can grab the calculator here and say sine of 62 and hit enter. Which tells us that sine is 0.8829 because we're going to go to 4 decimal places. So when we look at the first one here, sine of 62 degrees is 0.8829. It's helpful, yes.
Would there ever be like a 1?
For sine or cosine, no. Yes, unless we have like 2 times sine of 62, then it can be. But here, just sine and cosine by themselves, it's going to be 0. So number 9, cosine of 60 is 1/2, because we can come in here and say cosine of 60 degrees and hit enter, and it tells us that it's 1/2. Either one. 0.5000. Now we can also look at sine of 14. If we plug it in, we get 0.241. And lastly, cosine of 31 is 0.8571. 8571. Should be what? It's a 2. Because cosine of is 0.85716. So because the 6, it would round it up to a 2. And the reason we're going over this here, and we did see this a little bit yesterday, is that these actually have values. So cosine of 60 degrees actually has a value. It's an actual number. And what's helpful with this is that we can use them to be able to solve for the missing sides of a triangle. Missing sides of a right triangle. Now yesterday we went over the fact that sine of a given angle is equal to the opposite side length over the hypotenuse. And cosine of a given angle is equal to the adjacent side length over the hypotenuse. And depending on what side lengths we're given and which side lengths we're trying to find, will determine which one we want to use. Now for this triangle here, they gave us the angle of 26 degrees. Now if we wanted to find sine, or wanted to use sine, so sine of 26 degrees is equal to what? Well, sine is what over what? So it's the opposite side length over the hypotenuse. And what is the side opposite the 26 degrees? So x over the hypotenuse. Well, what's our hypotenuse? So we have x over 14. Now we just need to solve for the value of x. And for any of these here, the first thing we'll want to do is multiply both sides by the bottom of the fraction, which in this case is 14. Now when we multiply both sides by 14, the left-hand side is going to give us 14 sine of 26 is equal to, on the left-hand side, or sorry, right-hand side, we'd get 14x over 14. Now we won't have to write this out every single time. I just want to write it out at least once so we can see this, because here the 14 and 14 will simplify out, because anything divided by itself is 1. So those will go away. Now on the other side we have 14 sine of 26. Now as we just saw, sine of 26 is a number. It has an actual value, yes? And is the variable by itself? Yeah. So at this point here, I can pull the calculator up and say 14 sine of
equals 196.
and I have a feeling it says to the nearest tenth. So we're just going one decimal place, which would be, so x is 6.1. So 6.1, we can't really do that with those, but we can use cosine to find the other one. Because if we look at cosine of 26 degrees, well, cosine is adjacent over the hypotenuse. And the side adjacent to the 26 degrees is r, and the hypotenuse is still 14. So if we're given the adjacent side and want to find the hypotenuse, we can use cosine. And again, at this point here, we can both sides by 14. And the reason that we're doing this is so that the 14 here and the 14 here will cancel out, giving us y by itself is equal to 14 of 26. And again, at this point here, we can actually pull the calculator out and say 14 cosine of 26. 12.58, and if we're going to the nearest decimal, we would have to round up to 12.6. This here is 12.6. And that's all we need to do to find the values of x and y. Questions on this here? So really figuring out which one we use as sine and cosine is really determined on what we're given and what we're trying to find. So if we look at this one here, we are given the angle 65 degrees. If I wanted to find the value of u first, would we use sine or cosine? Cosine, because u, is it adjacent or opposite the angle of 65? Adjacent, it's next to it. So here we can use cosine of 65 degrees is equal to the adjacent side u over 8. Now what do you think we do next? Multiply both sides by 8, because we want to get rid of this fraction and hopefully get u by itself. So here we can multiply both sides by 8, which means that this 8 and this 8 will simplify, telling us that u is equal to 8 cosine of 65 degrees. And in the calculator, we can do 8 cosine of 65, which tells us that we have 3.38, which is 3.4. Now, what can we do to find t? Sine of what? Sine of 65 is equal to the opposite side t over 8, the hypotenuse. Exactly, we would multiply both sides by 8, so these would cancel, telling me t is equal to 8 sine of 65 degrees. And I think if, 7.3, yes. Because the 3.4 would have been the other side. Now, one thing that we can do to kind of check this is that we do know the three angles inside the triangle add up to be 180, or the two other angles are going to add up to be 90. So for this here, this other angle would be 25.
Because that's what he times both sides.
Because we multiply both sides by 8 to get the variable by itself. Does that make sense? Awesome. Now, 25 is the smallest angle, yes? And as we learned with our triangle inequalities, the smallest angle is opposite the smallest side, the biggest angle is opposite the biggest side. And for this here, the hypotenuse is opposite the biggest angle. So none of the side lengths should be greater than 8, the hypotenuse for this one here. Well, 25 is the smallest angle, so 3.4 should be the smallest side, which it is. And our middle side here should go between the two, which it does. So if we kind of look at the angles, we'll be able to somewhat see how it works out. Yes, sir? Could we have used the 25? Yeah. And we could have, if we wanted to, done the same thing with 25 degrees to get there. Or we can just use the 65. Because sine of 25 would have given us u over the hypotenuse. No, because you can get it all with 65. Okay. Because we can do it just fine with one angle and get everything we need. So looking at this here, if we wanted to find the value of x first, should we use sine or cosine? So going for x. So how does x and 35 work? Are they opposite or adjacent? Opposite, and we have 53, which is the hypotenuse. So we have the hypotenuse, which tells us I'm going to use sine or cosine. But if I'm wanting to find x, the opposite side of 35 degrees, we're going to use sine. Because sine of 35 degrees is equal to the opposite over the hypotenuse, and the opposite side length is x, and the hypotenuse is 53. So the first thing we can do in solving is, what is it? Yes, we'll multiply both sides by 53. It'll be the bottom, because we'll always multiply both sides by the bottom in solving. Because here the 53 and 53 would cancel out, telling us that x is equal to sine of So if we plug this in, we get.
Oh, you just plug that into the computer, that's the answer?
Yeah, we can plug that into the calculator, and it gives us the answer. Yes. In a bit. Scoot this over just a hair. Now we can do a similar thing to find y, but this time we're not going to use sine, we're going to use cosine. Because cosine of 35 degrees is equal to the adjacent side over the hypotenuse. So that would be y over 53. And again, we're going to multiply both sides by 53, which will tell us that y is equal to 53 cosine of 35. These would cancel. And y is what?
Seems to the exact same thing, but with sine.
One more time.
Like what we changed.
43.4. Yep. Yeah, that sounded better than 30. Yeah, because since the other angle is going to be bigger than 35, we expect the side length to be bigger. And that's it. Any questions on this here? Now, again, when we pick sine and cosine for the worksheet, because there's going to be a worksheet for the homework, not out of the book, it's not going to ask for both. It's only going to ask for one side length. So we have to determine, do we need to use sine or cosine? And the one we pick is given off of what we're looking for and what we're finding. So if we're given the angle and the side opposite in the hypotenuse, we'll use sine. If we're given the adjacent side length to the angle and the hypotenuse, we're using cosine. So it's all based off what we're given. So let's look at this one here. And I think the note sheets might be a little flipped. Okay, that's fine. Now, what's different about this one than the ones we just did? We're given one of the sides, not the hypotenuse. We're given the opposite side, yes? So if we're given the opposite side, the hypotenuse, which one would we want to use? Sine, because sine of 30 degrees is equal to the opposite side length, which is 20, over the hypotenuse, which is y. So this one here, we'll have to find sine first. Because if I tried to take cosine of 30 degrees, we would have the adjacent side over the hypotenuse. What's the adjacent side to 30 degrees? X, and the hypotenuse is. So we don't have both. Yeah, because if we have the value of y, then we could actually find x. So looking at the first one here, sine of 30 degrees equals 20 over y. And all the ones we've done so far, what did we do first? We multiplied by the bottom of the fraction, yes? What's on the bottom of the fraction here? So we can do the same thing and multiply both sides by y. And over here, the y and y will cancel out, telling us that y sine of 30 is equal to 20. Is y by itself? No. So to get it by itself, well, we can divide both sides by sine of. Because as we've seen already multiple times, sine of 30 is just a number. So we can divide both sides by it. So here the sine and sine will cancel, telling us y is equal to 20 over sine of 30, which is, I think you said 40? Yes. So y is equal to 40. And I'll show you here, because if we type this in a calculator, we can go 20 over sine of 30 and hit enter, and we get 40. So y for us here is 40. Any questions on what we just did here? Now, it is a little bit different than what we did on the previous ones. We just had to add one more step of the division. Now, for the other one, cosine of 30, well, we actually know what the value of y is now. It is 40. So for cosine of 30 is equal to x over 40. And we can go back to what we were doing before. So here we would multiply both sides by 40. And those would cancel out, telling us x is equal to 40 cosine of 30. 20 square root of 3. Yes. That should look kind of familiar. 30, 60, 90 right triangle. That's one of the ones we did already the other week with kind of our shortcut. But using sine and cosine, we can actually find the other angles algebraically. Any other questions on this here? Okay. Yes, sir. It is not actually, because if we look at it here, 20 square root of 3, 20 second square root of 3, it tells us that if we look at it as a decimal, it's 34.64. So it actually is less than 40, and it is greater than 30. So it actually fits right there in the middle, since it's opposite the middle angle. Any other questions? All right. Let's look at this next one here. So again, they gave us one of the side lengths, they didn't give us the hypotenuse. So we know whatever the value of x is going to be greater than 10 and greater whatever the value of y is. Now, for this one here, would we need to use sine or cosine first to find the hypotenuse? Cosine, yes. Because 51 degrees and 10, are they opposite or adjacent? Adjacent, so we would use cosine, yes. So we take cosine of 51 degrees is equal to the adjacent side over the hypotenuse. Well, our adjacent side this time is 10, and our hypotenuse is x. So what would we do next? We would multiply both sides by x. And here the x and x would cancel out, telling us that x cosine of 51 degrees is equal to 10. Now is the variable by itself? No. So we'll have to divide both sides by cosine of 51 degrees. Which here the cosine and cosine would cancel, telling us x is equal to 10 over cosine of 51, which tells us 15.9. And that there would be the value of x. Less than, because 15.9 is the hypotenuse. The hypotenuse is always going to be the biggest side in these triangles. So we're looking for y, expecting y to most likely be bigger than 10, because if we found this other angle, it would be 49, at 49. It would be, because 39 degrees. So we expect 10 to be the shortest side, and whatever we get for y will be in between the two. I'll erase this here so I have a little more room. So to find y, we're going to have to use sine of 51, which is equal to the opposite side over the hypotenuse. Y over 15.9. So at this point here, we're going to multiply both sides by 15.9 because these here will cancel out, telling us y is equal to 15.9 times sine of u1. And if we plug that in, we get 12.4. Any questions on any of this here? Do you want to see another example of one of these? Okay. We do have extra ones, but that is it for 12 or for 9.52.